Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. It's the end of June in 2019. I'm with a few dozen computer programmers, radar specialists, coders, engineers, and even national police authorities at the southern coast of Portugal near the Spanish border. We have the companies TNO and Thales from the Netherlands, Atos from Spain, and engineering from Italy, to name a few. And what are they doing? They're testing their work. This group usually works together from countries across Europe, but today they come together as a team in order to test a solution to a growing problem: drug smuggling. Of course, it's not a new issue. The bad guys are constantly looking for innovative ways to carry out cross-border drops. In this case, UAVs. Unmanned aerial vehicles are a viable solution for the smugglers because they fly low and slow and under the radar. Literally. We're mainly talking about drones here, and to be more specific, we're talking about the vulnerable border between Europe and Africa. With the possibility for the bad guy to send a virtually untraceable drone across borders with a payload, it becomes abundantly clear that a new detection method is needed. And that's where the ALFA project comes in. ALFA is a EU H2020 funded project which not only intends to find these low-flying objects, but also categorize them and determine their threat level and even predict where they might land. That's the plan anyway. I'm your host, Peter Ballant from Technicon, and today we are just outside Faro, Portugal, on the sunny coast of Castela Vella. We are fortunate enough to tag along and see how ALFA is progressing. The project has been ongoing for almost 3 years. The consortium is made up of 9 partners from 6 European nations, and what we're watching today is a pre-demo of sorts, a way to bring everything together to test the various systems as an integrated whole for the first time. Call it proof of concept, if you will. Over the next few days, project partners will test their wares from a makeshift control center centralized in the fortress of Castela. And this is a castle which dates back to the late 1700s. With radar, photo, computer, and antenna apparatus in place, the team works tirelessly to work out bugs and snags. To get more information, we were lucky enough to sit down with José Ramón Martínez from Atos in Spain. He is a key player in the integration and prediction elements of the ALFA project. Let's talk with José.
Well, ALFA is, let's say, the evolution of the fight that goes between the smugglers that try to introduce drugs from the north of Africa, especially, to Spain and Portugal, is the evolution of the fight against the police forces. These days, or in the past, let's say, they were using ships for going to Africa, from Africa to Spain, and also to Portugal. But now the Spanish police, the Guardia Civil, and the Guardia Nacional Republicana from Portugal, they install radars. So these radars detect the ships coming. So there has been an escalation of the in the fight of the smugglers against the police. And now, these days, they have started to use helicopters, planes, and small drones to introduce the drugs, because the distance between Morocco and the south of Spain, especially, is less than 15 kilometers. So it's very simple to have let's say, a helicopter, usually in Spain, for example, and they go to the north of Africa in 10 minutes, let's say, they load all the drugs, and they go back to Spain, and they disembark everything. And this takes like half an hour, let's say. So here is when ALFA enters. The idea is that we are going to introduce a lot of ways of detection, radars, electro-optics, which try to see the plane. Also, we are trying to intercept the communications of the plane or the drone, and then put this information together to try to know and to detect these small drones, small helicopters coming to Spain or Portugal, and then presenting this information to the operator to detect them. Also, in ALFA, we also want to foresee where these helicopters or planes are going to land. And we have a model for that is able to predict or try to predict where are these people going to land and where are these people going in general terms, what are the routes they are going to follow in the air. Why? Because the police has no unlimited medium, so they have to decide which way to go, let's say. So this is ALFA. The idea of evolution from the status that is right now, which is smugglers bringing things to Spain and Portugal by ship, and smugglers these days starting to go by helicopter, drone, etc. So we are trying to detect that.
And tell me your background and what makes you interested in this project and why you decided to get involved with this project.
Well, I work in Atos Spain. And in Atos Spain, we have an area of R&D. We have a lot of stuff there which is related with security in general. So for us, it's a very interesting project because we can use our expertise to, in this case, try to detect not the plane itself, but try to predict where these helicopters or planes are going to land and what are the routes they are going to follow in order to help the police detecting them. As you know, the European projects are made by a lot of European companies together, and the idea is that we put together new technologies to respond to a certain challenge. In this case, the challenge is how to detect these people coming from far, and then how to predict where are going to put the drugs or land, etc. So this is my background.
With ALFA, who's the big benefactor then? So when you have developed something that works and it's been tested, who will benefit the most?
Well, of course, the LIAs, the police departments, in this case the Guardia Civil from Spain and Guardia Nacional Republicana in Portugal, firstly. Secondly, the police departments that are responsible for smuggling in all the Mediterranean basins. And then Europe in general. The idea is that we are developing something that in the future they will use in combination with what they already have. These days, especially in Spain and Portugal, what we have is radars, maritime radars. And with these radars, they detect a lot of fast ships coming to Spain and Portugal, and they intercept them. So the idea for us is developing the things we have in ALFA and putting them together with these radars that we already have in place. And with these things together, we will have a whole picture of, let's say, everything coming from Africa, especially for drugs and smugglers, but also can be used, for example, for immigrants. It's very interesting because these days there is a big problem of people getting drowned in the Mediterranean because they are trying to reach Italy or Spain, for example. So we can detect together, let's say, the things that are coming by the air and the land, and then with that information, the LIAs can use the resources that they have, which are limited, in a good way, let's say, to try to save lives, to try to avoid all these things coming to Spain or Portugal, Italy, etc. The future evolution of something like ALFA is the integration with this kind of radars that they already have.
Now, you mentioned drones being used as a vehicle for drugs. Is it possible that a drone can be programmed to go to from a certain location to a certain location, and basically then is unmanned, it's uncontrolled, it's just has GPS coordinates programmed in?
Yeah. You can do it automatically. You can program a drone these days, and he will go on his own anywhere. You don't even need GPS. I mean, you can use the terrain as a signal. You can detect, for example, that you have a river here, or it's very simple, or just leave the drone going in a straight line, let's say. It's very, very inexpensive solution. This is the point. You cannot transport a lot of drugs, but it's very cheap. So being so cheap is easy. So you can send, let's say, 100 drones at the same time without much cost. And if 9 out of 10 reach the area, it's okay. Yeah, and you can program them in any way. You can program them going automatically somewhere or even returning home automatically these days. Yes, this is very advanced these days. It's very simple, very, very simple.
Okay, so you're using the ALFA technology to sort of keep an eye on the maritime borders, keep them safe, to detect drones in this zone. Where else can you see this technology being used, perhaps in a metropolitan situation or something other than maritime?
Yeah, all kind of security stuff. I mean, everywhere where the people can be gathered is something that the European Commission and the national governments are willing to protect. So yeah, all these kind of areas. I mean, if you have a refinery, you want to detect drones coming there. You have a nuclear facility. This has happened in France already. You want to detect these drones coming and then intercept them beforehand, before creating any problem. So yeah, it's something that can be used in many, many different situations.
Okay. You're working on a proof of concept right now. Is it possible that this sort of evolves into a commercial product then?
Well, yeah. The idea is, especially for the Commission, is trying to create a commercial products with these kind of projects. I mean, the European Commission is not interested in throwing money against nothing. They want companies to go together and create products. But usually what happens with this kind of projects is that the technologies we are creating, for example, the radars or the electro-optics or the modules we are creating in Atos, can be reused and solved for the same kind of problems, maybe isolated or maybe in combination with other products. So we are creating the technologies that will be used tomorrow for detecting these kind of things.
So it's the end of June. We're in the country of Portugal on the southern border. The ALFA project has gathered together 25 individuals, all project partners for ALFA. Tell me, what do you hope to achieve in these next few days?
Well, we have here the first, let's say, real proof of concept of ALFA. The idea is that at the end of the project, we will be here also in Portugal, showing to the public and to the European Commission the results of our project. So here what we are trying to do is testing everything together, let's say for the first time with real planes, real helicopters and real drones. Everything has been integrated beforehand. We know that everything works together, but we have to check if in the real conditions that we have here with the wind, with the sea, with the, the ships moving in the sea, for example, things like that, we are not having any issue. So the idea is here we will fly helicopters, real helicopters, autogyros, by the way, drones, and we will see the results in the tool. Why? Because that way we can fine-tune the details in order to have a perfect product, let's say, for October.
And this is a pre-demo, meaning that there is actually a demo then again in October.
Yeah.
Final.
That's it. Yeah. In October, we will make the same thing with real helicopters, drone, planes, etc. For real, let's say, with public, especially with the European Commission, which is paying at the end for that. So we will show them how things work for real.
Okay. I wanted to touch on this idea of predicting a spot where the bad guy will land.
Yeah.
How is this done? I mean, just in layman's terms, what do you use to make these predictions?
Good question. Yeah, this is the part of Atos. Let's say in this project we are making the models to predict what this helicopter is going to land, for example, and also we are doing the prediction of the route that it will follow. Well, at the beginning, the idea we had was trying to do this, let's say, modern stuff of self-learning, deep learning, EA things that are very in fashion these days. But for that, you need a lot of information. You need a lot of real cases happening. You need to know real cases to train networks, etc. So this is not available, let's say. So instead of that, we went for the, let's say, more simple solution, which is making a questionnaire for the police forces. The good idea, or the better idea, will be making this questionnaire for the bad guys, I suppose. We went to the people who is on the land, actually on the land, trying to detect these people. And we asked them what were the ideas, the gut feelings they had about why the bad guys decided to do that, and which are the ways they do that, and what is the experience they have. So we extract this information from them. And with this information, what we built is a software piece of code that uses two things, let's say. First thing, uses the weather prediction, because it's very important. I mean, if there is wind, if there is a big storm, for sure these people that they are flying a helicopter that this goes very low because they try to avoid radar, etc., they will avoid this weather. And we also use the terrain. We have, let's say, terrain information. We know how is the land, let's say. And using the questionnaires, we know which are the preferences they have for landing. For example, we find out that these people prefer to have big spaces with big warehouses. Why? Because what they usually do is they storage the planes or helicopters in Spain, not in Morocco, and then in these big warehouses, they take off from Spain, they go to Morocco, they load, and they go back to this place. So we use this information to give, let's say, a punctuation, to give a score to certain areas, to say, okay, this area has a big space for landing, maybe it's not a landing strip, but it's good enough, has a warehouse nearby, so we give a score for that. And with this information and the weather prediction, I mean, here there is no wind, here there is a lot of wind, we give a probability of landing. For example, we have another kind of information. We know, for example, for sure that they try to avoid urban areas. Why? Because they go very low, so people are seeing them passing and they can call the police. So they try to avoid that. So with this kind of information, we gave a score of probability. We say, okay, provided that they come from the sea and the wind is okay, we know for sure that they will avoid the villages here in Portugal, for example, and they will go inside, not far, let's say, to an area which is open with a certain warehouses. This is for landing. For route prediction, it's even more challenging. What we did for route prediction, we are trying to say to the police, okay, the plane is here, but we are saying that the plane maybe, with a high probability, will go this direction or that direction. What we created is something like routes based on rules of probability, saying, okay, what we know is that they follow certain reasons for doing things. For example, we know that they try to avoid flying a lot over the sea. Why? Because in the sea, there are no mountains, there are no obstacles, so it's very, very simple for the radar to see them. So we have a rule, which is avoid to fly a lot over the sea, go in a straight line to the land over the sea. So we created a lot of rules based on things we think are reasonable, based on the questionnaires. For example, we know for certain that they usually follow the border between Spain and Portugal. Why? Because if you fly using the border, you are creating a problem for Spain and Portugal because they have to agree on who is going there, etc., etc. This takes time. For example, we know for certain that they are using certain river valleys to follow them. For example, it's very simple from the air to see the Guadiana Valley. You can follow it easily. There are no towns until Seville, so it's simple. So we put these rules together in a software tool, and with this information, we predict the probability of following certain paths, saying, okay, now the plane is here, it's going that direction, so we say, okay, it will follow this path or this path with this probability in order to help the police to decide where to send the people, where to send the cars or the helicopters or the mediums they have.
What kind of air vehicles are these that you're looking out for? These are the vehicles that are currently flying under the radar, so to speak. We mentioned drones.
Yeah.
Small helicopters?
Small helicopters, yeah. Low flight vehicles and planes that can land anywhere. There are a certain category of planes that can land everywhere. This means that they can be landing in any spot of land plain enough. You don't need to have a real airport to land them. Maybe they can land in 20 meters, this kind of stuff. They are usually very slow moving. Let's say they are not commercial big planes, of course, and they fly very low to avoid the radar. This kind of stuff. So this includes helicopters, small helicopters. This is called. This includes certain kind of planes, and also drones.
So a drone is about the same size as a bird, a seagull, perhaps.
Yeah.
How does ALFA know the difference?
Well, it's not easy sometimes. It has to do with the movement of the, let's say in this case, of the wings. In the helicopter, the way the wings move create a certain pattern that can be, let's say, that you can tell in a machine the difference with a bird. This is mainly the thing. So the way things move is used to tell the difference between between birds and also other things, planes, for example. It's not easy. And sometimes you have false detections. This is the reason we are also using the visual aid of the electro-optics. So the idea is you are detecting something with the radar, and then you are checking that, visually speaking.
Good. Well, it's a very interesting project, and I wish you success in the next few days as you conduct this pre-demo activity. And the project is done at the end of the year then, is this correct?
No, it's in October. This project will end at the end of the year. It's 3 years.
Okay. Good luck with finishing up the project, and we can't wait to check in a few months to see how things finally went then. So thank you.
Okay, thank you.
This podcast has been brought to you by Technicon. The ALFA project has received funding from the European Union's Horizon 2020 Research and Innovation Program under Grant Agreement number 700002.